Alright, class, can you read the question? For all values of x, doesn't matter what x is, any value of x you like, the left hand side will be equal to the right hand side. Do you want to teach? Okay, so now our goal is to find the value of a, b, and c. I think that I can observe by observation a equals to 3. Who needs help for this? All okay? Okay, so that's one down already. Now, when x, I want to try a certain value of x such that I get rid of as many things as I can. What is a good idea to substitute x into x? Okay, let's try. Some of you say 2. Yes, I agree. So that this will disappear, right? It becomes 0. So I'll substitute x equals to 2. Let's see what happens. When x equals to 2, I've got 3 to the power 3, which is 8. We can do that mentally, okay? So I think you can also. Let me skip a few steps here and there. Plus 4 times 4 minus 34 minus 11 equals to c. So we have another one already. So this tells me that c must be equals to, looks like I need to use my calculator, 24 plus 16. How much is that? 40 minus 34, I get 6, minus 11, I get negative 5. Is that correct? Yeah. Then now I'm only left with b, right? What would you like to substitute in next? Or you can choose, okay, you have many options right now. You can choose to substitute another value of x because you already have both of the unknowns, just one unknown left. Substitute any value of x you like, solve for b. Alternatively, you can expand everything out and you compare coefficient. What do you prefer? Sub, right? Because if you expand everything out, it's wasting a lot of time. What is a good value to substitute in? 0. Wow, smart people, because when you substitute 0, this one becomes 0, this one becomes 0, this one becomes 0, right? Right? So it makes things easier for us. You can choose to substitute x equals to 1. It is not too difficult also, isn't it? Okay, but I agree with you. I would like to let x be equal to 0. When x equals to 0, I've got negative 11 equals to a. Value of a is 3. 3 times 0 plus 1. 0 plus b. 0 minus 2 is negative 2, then minus 5. Agree? All okay with this? So let's simplify. Negative 11 equals to, okay, 1 over here. B, negative 2b minus 5. 2b equals to 6. B equals to 3. Can? Yes. Anybody got the same answers using other approaches? There should be lah. I believe there would be. Okay? So what this means is that it is true. When I substitute different values of x, let's say some of you chose x equals to 1, you would still get the same answers for a, b, and c, provided you did your steps correctly, without careless mistakes. Is it difficult? No, it is not. Okay, so let's move on to question 2. For all values of x again, we've got 6x cubed plus 7x squared minus x plus 5 equals to ax plus b 2x plus 1 x minus 1 plus c. Right, which is the easiest to find out now? A again? C. Okay, let's try A, okay? So by observation, okay, what shall I write? A equals to 3. Wow, you skip one whole step. Can we have 6 equals to, over here this is the only way I can get an x cubed term, right? So it must have been 2a, isn't it? This is the only way I can get an x cubed term. Therefore, a equals to 3. Agree? Okay. What shall we find out next? What do you want to do next? Find c? How do you want to find c? You want to sub, okay, sub x equals to 1 to find c, is it? To find C. Okay, yeah, you are, yes? Huh, what? P bracket 1, is it? Did you define what P is? No, you didn't. But if in the first step, you say that, over here you say let P equals to 6x cubed plus 7x squared minus x plus 5. You say let Px equals, Px over here. Let Px equals to that. Then yeah, subsequently you can use P1 equals to blah 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 blah. Okay? So you must define it first. Otherwise you suddenly throw in a P, I don't know what that is. Okay, so early on you were saying that you want to let x be equals to 1 to find the value of C. Okay, so let's do that. Sub x equals to 1. So 6 plus 7 minus 1 plus 5 equals to C. 13, 12, 17. C equals to 17. Is it correct? Okay, I'm not checking the answers. Okay, next, what do we want to find out? B is left, isn't it? Okay, how should we find B? Sub x equals to 0. Yeah, sounds good. 5 equals to B 1, negative 1 plus 17. So B equals to 12, correct? Is it correct? Yeah. Okay, let's look at the steps. Oh, wow, look at this, question 2. These are the only steps required. Not difficult, right? Do you need more? Do you think you need more practice? Can we just do one question? Let me see. What would you like to do first? Let x be equals to 5. Okay, let x equals to 5. So we have a 15 minus 2 is 13 equals to 55 minus 16. So a equals to 3. Then what do you do next? Sub x equals to 0 in order to find b. How about this? Let me think about this constant term over here. I've got a negative 16, right? How then will I get a constant from my left hand side? You see, a is a constant, right? Times negative 2, I get a constant, right? I've got a b over here. I've got a 5, right? So these two are also constants, right? Do you agree that if I evaluate the parts in blue, I'm supposed to get negative 16? Because they are constants? Can I do that? Okay, let's see what happens. So what I'm trying to say is that a, which is the value 3, 3 times negative 2 plus 5b equals to negative 16. This is what I'm trying to say. Therefore, 5b equals to negative 10. b equals to negative 2. Is it correct? Yes. So is this the same way as you did it? Yes. Are you sure? Same way? Yes. Who did it this way? Who did it my way? I'm guessing that most people chose to let x be equals to 0 or something else. But my point over here is to show you there are many ways to do it. Okay, and this is one logical way to do it as well. You get the same answer. And the purpose of showing you this is, if next time when questions become more complex, we can also use observation to quickly identify the constant term. Just like you've been using observation to find out the coefficient of the x with the highest power, isn't it? For our homework practice 6, we've been using observation to find out the unknown, which is the coefficient of x with the highest power. Similarly, it can be done for the unknown constant. Okay? Okay, first step, what do we do? 1 divided by 7. Can or cannot? Cannot, right? So I move on to the next digit, right? So what do I do now? Where do I put a 1? Here lah, right? Then what do I do? 7, then minus, right? What do I have? 3, then I bring down the 0. What do I do next? 4 times 7, 28, minus 2. Then remainder 2. Easy? Hey, you must remember this. You go and practice. Because all of you very familiar, very used to using your calculator, right? But you must know how to use this. Why? I will show you. Division of polynomials. Okay. So over here we have names. What is this 100 over here called? It is called the dividend. Okay. This 7 is known as the divisor. This 2 over here is known as the remainder. And what about this 14 over here? Quotient. Okay. So there is a relationship. What is the relationship? Is relationship between 7, 14, 2, and 100. Without looking at a textbook, can you tell me the relationship? Okay, how about this? Can you form an equation, okay, that includes 7, 14, 2, and 100?
7 times 100 equals 7.
Wait. Too fast. Okay, one by one. 100 equals to?
7.
Okay, now we have, what is this called again?
Dividend.
Okay, dividend equals to? What is the 7? Is the divisor. Okay, 14 is the quotient. Then this is the remainder. Okay, difficult or not? Don't tell me difficult. Look at your textbook at the bottom, page 12. Do you have the same thing? Dividend equal to divisor times quotient plus remainder. Same? Need to memorize? No need, because we all know it from primary school maths. Now, we are going to use this same algorithm. This is known as an algorithm. Okay, it's just a big word. Next time you'll use it more, okay? For polynomials, we are going to divide. Let's take a look at work example 7. Divide x cubed plus 2x minus 7 by x minus 2. It is okay if you don't remember which one is the divisor, which one is dividend. I can't remember the names. The most important one is the remainder. You need to know which one is remainder. Easy, right? I'm sure everybody knows what the remainder is. But if I ask you to divide this by this, can you at least place them in the correct position when you divide?
Yeah.
So what goes where? What goes over here? X minus 2. That's straightforward, isn't it? X minus 2. And what about the inside over here?
X cubed plus 2x.
Plus 2x minus 7, yes? All agree? This is minus 7. Okay, so far? Now, one thing for long division, this is called long division of polynomials, I need you to be very careful with the dividend over here. I need you to arrange them such that the highest power comes first. Do I have the highest power?
Yeah.
First?
Yeah.
X cubed, right? What is the next highest power?
2x.
Highest power.
1.
No, it is actually power 2. Where is power 2? Where got power 2? Where got power 2? 0x squared. I require it to be in this form. Later I'll show you why, okay? So in this question, they didn't have a x squared term, right? So we are going to introduce it. And this x squared term is actually 0x squared because it's 0, isn't it? Next we have plus 2x, then minus 7. Okay? Why got x squared? Original question don't have, right? But this is the rule that we need to follow. I will show you why later on, okay, when we do the steps. We require the polynomials to be in descending order for the powers. So 3, if you start with 3, then it must be power 2, power 1, power 0. Get it? Here we have x power 0 lah. Okay? Sometimes the question doesn't have an x squared term. Like that. This is the original question. So I want to follow the rule. I place in the plus 0x squared. What if we don't? Then you will have some problems later on. Okay, so now is the time for me to illustrate why it is important. When we do long division, it is very important for us to be very neat. Okay, I'm going to draw in some invisible grid lines over here to help us space everything out properly, okay? Now, remember when we did 100 divided by 7? I tried to divide 1 by 7, right? But I couldn't. So I combined the next two numbers, 1 and 0, and I divided by 7, correct? This time I could do it. Okay, and I found the value 1. 1 times 7 is going to give me 7, which is just smaller than 10. That is the reason why I chose 1 over here. We're going to apply the same idea. Okay, I've got x cubed over here. I've got x minus 2 over here. Is there something that when multiplied by x gives me x cubed?
X to the power of 2.
Think about my question again. Listen carefully. Everybody keep quiet. You must think through this. Is there a number that when multiplied by x gives me x cubed? What is it? Okay, it is not a number, it is actually x squared, right? So x squared is what we require. Okay, so I put x squared over here. Why do I put x squared over here?
So that
Look at what I've drawn, all my lines. I put all my x squared terms in one column. That is the reason. I need things to be very, very neat. Get it? Okay, so I've got an x squared. When I multiply by x, I'm supposed to get a x cubed term, right? Okay, so let's do that. X squared times x times the whole thing over here. This is my dividend. Okay, so x squared times this whole thing. I will get x cubed, right? What else do I have? Minus 2x squared. Okay, what should I do with these two? What do we do? After we took 1 times 7, then I got 7. What did I do to it? Minus it off, right? I do the same thing. Put a bracket, minus it off. Okay? Draw a line. X cubed minus x cubed, what do I get?
0.
Is it a coincidence? No, we planned for it to be that way. I planned for x cubed, x squared over here, so that when I multiply by x, I get the x cubed. That's why it must disappear. Okay, yes?
How did you get? Why must suddenly times?
What do you mean?
Your
Why must x squared times x minus 2, is it?
Yeah.
Let's look at this. What do we have after we got, after we identify 1 over here? What do we do to the 1? Times 7, right? Same thing lah. Then after that we identify 4, right? Then 4 times 7 we get 28 lah. We always multiply. And then we subtract it off. Okay, moving on to, back to this. So I subtract it off. It is not a coincidence that my x cubed disappears. I want it to be that way. I planned for it to be that way. So when I subtract it off, do I have x cubed already? What about x squared term? What is left?
X squared.
So we have 0x squared minus 2x squared, right? What do I have left?
2x positive first.
2x squared. What should I do next?
Bring down the 2x.
Bring down 2x, right? Is it a plus or minus?
Plus.
Plus. Okay. Okay so far? What should I do next?
Find another.
I need to find something over here that when multiplied to this will give me 2x squared. Because now I want to get rid of this 2x squared. So what over here multiplied by x gives me 2x squared? 2x. All agree? Plus 2x. Agree so far? No. Who needs me to slow down or to explain? You must sound out. Okay? One more time, okay, we haven't done this part yet. After we divided, we get 2x squared, yes? Then I bring down the 2x. So I need to resume my algorithm. I need to continue with the next number. After I bring down, I subtract, I get 3. I bring down the 0. Now I need to find another number over here, such that when multiplied by 7, gives me something that is just smaller than 30. And we know that x equals to 4. We multiply down, we get 28. Yes? Okay, so similarly, I've got 2x squared plus 2x. I want to find something over here that when multiplied to my dividend gives me something very close to 2x squared plus 2x. what is the something that when multiplied to x minus 2 gives me something very close but not exceeding 2x squared plus 2x. So this must be plus 2x, because mentally I must be able to do this. Positive 2x times x gives me 2x squared. Mentally I must do that. Okay, so when I multiply it in, I get 2x squared. So 2x times x is 2x squared. Then what's next? Minus 4x. Okay, this is the multiplication. Then what do I need to do with these two sets? Subtract, right? Is it just like that? With a bracket, yes. Now, 2x squared minus 2x squared, what do we get? Is it a coincidence? No, we planned for it to be that way. 2x minus negative 4x, what do we get? 6x. What do I do next? Bring down the 7. Minus 7. Can you tell me what goes in? What's the next one? Positive or negative? Plus 6. 6 times x. 6 times negative 2. Negative 12. Minus it off. What do we get? 5, yes. What is the remainder? Okay, so it's over here lah. Remainder 5. This is long division. So I'm going to ask you the exact same question. Are you able to write down an equation relating 7, 14, 2 and 100? Yes, you can. Are you able to write down an equation relating x minus 2, x squared plus 2x plus 6, 5, as well as x cubed plus 2x minus 7? What is the relationship between 1, 2, 3, and 4? Okay, don't tell me 4 equal to. Write down the equation now. Write down the equation on your own. Okay, those of you who need help, you may look at the screen now. Something times x gives me 4x cubed. What is the something? 4x squared. I place it above the x squared. So we get 4x cubed plus 8x squared. Subtract it off. With brackets. Some people never put bracket. Then it looks like this. Do you think they are the same? They are different. You must have the brackets. 4x cubed minus 4x cubed is not a coincidence to be 0. 3 minus 8, negative 5x squared minus 16x. At this point, some of you will stop because you have a negative. But don't worry, listen and follow my instructions. What multiplied by x gives you negative 5x squared? Negative 5x. I'm not teaching you anything different. So negative 5x times x gives me negative 5x squared. Negative 5x plus 2 times 2 gives me negative 10x. Subtract them off. You will still see that 5x squared and 5x squared cancel. Becomes 0. We meant for it to be that way. Negative 16 plus 10. Negative 6x minus 12. What multiplied by x gives me negative 6x? Negative 6. So negative 6x minus 12. Subtract, what do we get? 0. Any remainder? No remainder. So in summary, last part, 4x cubed plus 3x squared minus 16x minus 12 is the same as x plus 2, 4x squared minus 5x minus 6. Okay? Yes? Oh, got 3 brackets. Did they say factorize completely? They didn't. You don't need to. But if they say factorize completely, then you should. In this case, apparently it can be factorized. Okay, I'm too lazy to do it. What are the answers? X minus 2 and 4x plus 3. Okay, yes? Where plus 0? Oh, no need, no need. Yes? Yes. Any other questions? Okay, then let's turn to page 14. At the top, what do you see? Okay, at the top of page 14, this is what you see. X maybe power 5 plus bx power 4 plus cx power 3 plus blah 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 plus okay, let me just finish here. Dx square plus ex plus f. Right? This is a polynomial. The powers are positive indices, including x power 0 lah. So these are polynomials, these are functions. And whatever value of x I substitute inside here, let's say x equals to 1. All I need to do is to just change all these to become 1. And I will have my value, right? Different values depending on the values of a, b, c, d, e, and f. Okay? So we see that we can actually express our polynomials in this form. Any polynomial, as long as it has a factor. Oh no, it doesn't have to have a factor. Any polynomial when divided by another polynomial will give you a quotient and a remainder. Okay, let's look at previously, the previous question. This is what we had. This is my px. So px equals to 4x cubed, blah, 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 blah. My x plus 2 is actually my dx, my divisor. This is my quotient, qx. Do I have an Rx in this case? No, there is no remainder because remainder equals to 0. Okay? Is it true that for any value of x that I put in, let's say x equals to 0, left hand side will still be same as right hand side?
Yes.
Yes. If I put x equals to 1 million, left hand side still equal to right hand side?
Yes.
You are right. So that is why we are ready to go into this very exciting topic called remainder theorem. Yes. Yes. Okay, this one is a very exciting one. Remainder theorem. Okay. Now, let's take a look at work example number 8a. Why the pen so thick? Okay, work example 8a on page 16. I promise you, it is quite exciting. Okay, now find the remainder when 4x cubed minus 8x squared plus 9x minus 5 is divided by x plus 2. Okay, ignore the working shown in the textbook. I want you to find the remainder when this is divided by x plus 2. Can you do that? How long do you need? Okay, so class, can I show of hands who got negative 87? Look around. Those who didn't get it, look around. Find these people for help, okay? I will not show you the long division. Answer, negative 87. Now, class. All of you pay attention, look at the screen. Look up, Roshini, Darius. This is what we had in the previous few pages. Px equals to the dividend x times the quotient x plus the remainder x, right? Let's do some substitution. What is my polynomial? What is my dividend? 4x cubed minus 8x squared plus 9x minus 5 equals to the divisor. What is the divisor? X plus 2, right? Then multiply by quotient. Did we do the quotient? Suppose I don't do long division. I don't know what's the quotient, right? Then plus remainder x, correct? Is this correct so far? Based on the question, what is it that I want to find out? What does the question ask me to find out? Remainder. This is what I want, right? Okay, this is where the magic happens. I only want Rx. What do I want to get rid of? I want to get rid of everything else. I want to get rid of x plus 2, I want to get rid of qx. I only want rx, which is my remainder. Can you give me a value of x to substitute inside?
0.
Think about it. If you let x be equal to 0, what happens over here? 0 plus 2 is 2, right? 2 times quotient, do you know what that is? Don't know. I want this to disappear. What happens when x equals to negative 2? Think about it, what happens? 0 times q. Do I know what qx is? Do I know what qx is? Do I care? I don't care. So it becomes 0 times this becomes 0. So I get remainder. When do I get remainder? When x equals to negative 2. Can I start negative 2 here?
Yes.
Let's see whether we get the same answer, okay? So remainder, look, class, remainder equals to P2. Agree? Agree or not? Because this is my polynomial, right? Px is equal to this, isn't it? So P, when I substitute x equals to, negative 2, when I substitute x equals to negative 2, I am supposed to get my remainder, right? Let's see what happens. 4 negative 2 to the power of 3 is negative 8. Minus 8, negative 2 power 2 is 4. Plus 9 times negative 2 minus 5. Okay, I don't skip step yet. Let's see what happens. Equals to negative 2 plus 2 times q with a negative 2 over here plus the remainder, right? Remainder. Let me just write down remainder. E-M-A-I-N-D-E-R. Correct?
Yes.
Okay. Left hand side, what do we get? Negative 32. What is this? Negative 32 minus 18 minus 5. Equals to 0 times q. I don't care what q is. It becomes 0. Equals to remainder. How much is this over here? 81. Really? Wait, how much is this? Wow, why you all don't want to use your calculator to help me?